how many sessions do I have where I haven't uploaded a video? 2, maybe even 3. Let me try my YouTube real quick. Duality. What the heck? Sorry, so currently work is kind of slow, so I'm gonna do some coding. EdisonArchives, let's take a look. So allegedly, I have to upload 6, 7, 8, and potentially 9 today. Oof. A little bit, that's a little tough. It's a little tough, man, a little tough. So in terms of our schedule, I think I have until Friday to finish. Yeah. And I'm not even done with sliding window. But I think I have 2 weeks to cover this, 2 weeks to cover this, and I think 2 weeks to cover this. So if I can just power through these next 2 sections and the rest of this one, I think we'll be okay. Because I'm on problem challenge 3. If I limit my time, it's only 4. Okay, one more. Yeah, so I can finish this one today and then start on 2-pointer later. But I do need to start gaming to like give my brain a break. But there's so many 2-pointer problems. So hopefully we can get through all these in a reasonable pace. Gotta enunciate. So where did I leave off? This solution, no. Yes. This solution sucks. Does not work. Or it does work, but it doesn't work. It works sometimes, but it doesn't work all the time. It's weird. So basically it's saying we're having a key error. And that's mainly because D is not in our frequency thing. So I could, I could say if S at, and this is bad. I don't want to do this. I'm just throwing stuff at the wall at this point. Okay, I'm gonna add an extra part of that. And this is gonna work, probably not, but look, it returned nothing though. The string never ran. Frick. All right, it's over. I don't have time for this. I gotta get through these problems. Solution time. This is 3, right? So I didn't say. This must be 3. Explanation. The problem involves a sliding window pattern and a simulation to permutations with one difference. In this problem, we need to find a substring having all characters of the pattern, which means that the required substring can have some additional characters and it doesn't need to be a permutation of the pattern. We will keep a running count of every matched instance of a character. Whenever we have matched all the characters, we try to shrink the window from the beginning, keeping track of the small substring that has all of the matching characters. We will stop the shrinking window process as soon as we remove a matched character from the sliding window. One thing to note here is that we could have redundant matching characters, i.e. we may have 2 A's in a sliding window when we only need 1. In that case, we will counter the first A. We simply shrink the window without decrementing the match count. We will decrement the match count when the second A goes out of the window. Simple enough. So we have a start, match, and a substring start index. We have a min length, which I wasn't even... I was tracking the min length by doing something else. By doing like a start and end. But okay, they use this length plus 1 and a character frequency. Cool, we're adding characters to a frequency. To start at the count, it says attempt to add So when we look at a new character, if it's in there, decrement it once, and then if it's greater than or equal to 0, increase matched. So while matched equals to length. So if we loop through some or all, some portion of the array or the string, if matched equal to the length of pattern, when we have enough, what did I say? If we've matched everything in the pattern, right? If min length greater than a window, so I had something similar, right? If our current min length is greater, when we want to shrink it, we want to say min length now gets the new one, and your start is not the new start. So I had something similar to that. Cool. The left character is here. Window start gets incremented, and if the left character is in there, then we say and it's equal to 0, match. Otherwise, add it back, because we could have multiple A's, right? And it says if min length greater than string, length of string 1, if our length is greater than the length of the string, if it remains greater, never got changed, then return string at substring start to substring start plus min length. There's no end pointer here, so I guess we just use the start plus the min length, which is the length, I guess. Length plus 1, which is length, which is not inclusive. Wow. Interesting. Very, 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 very interesting. First of all, let me adjust my setting. Can I just turn that off? VS Code, paste, without formatting, yeah, but without indentations, what I want. Ugh. Stack Overflow, please. Format on paste. Turn that shit off. Yeah, I'm turning that shit off. I need preferences. What? Preferences. Format on. So my format on paste is not on. No. Can I look at JSON, please? I can just use it. Formatter. Format on save, true. Okay. I see no format on paste, so I don't know what it's doing exactly, but okay. Weird. Yeah, weird. I don't care that much. I don't care that much, but I care a little bit. It's okay. Cool. Okay. I'm so tired. So on paste, it literally just formatted it. Is that right? Then what else? While if left character. Function seems to run. Crazy. Add some test cases. Why do I have no personality today? It's kinda... I feel like I should be saying something. Okay. Woo! I'm missing my expected. I don't want to copy all that shit. Okay. I'll accept it. 135. Last one. Oh, last one. Yeah. Let's wrap this one up and let's take a break. I've been doing a lot. Let's take a break. Let's watch some TV. God of War, maybe. Do I want to play games? A little bit. I want to DJ a little bit. I'm kind of hungry a little bit. A little bit. Let's see if anyone's in Discord. Can I drag anyone to Discord? No one's in Discord. No one's online. That's because Javon's going to be, I think, here. So this is not the best weekend to be gaming, really, actually. So I think I'll just DJ for a bit. Anyway, runtime complexity. If I take a look, you're dealing with me. Oh, this stuff deserves to be a little bit deeper, if I'm not mistaken. Am I crazy or am I crazy? Why did it work both times? I'm a little suspect of that. Why do I get so tired when I start doing this? I get so sleepy. Kind of like reading. But I don't want to go to bed though. I want to work. I have to train myself to become a machine. N plus M. I'll say O of N. Well, it's O of really. I kind of want what's it called, Lantern tonight again. Yeah, it's just good. I don't understand why it just hits right these days. Yesterday it was so good. I was like, oh, this chicken's strangely delicious. They told me yesterday it's gonna take 7 minutes to make my Mongolian chicken. Mongolian chicken, 7 minutes? What? Or N is the... and pattern. The space complexity. And that should be O of N. In the resulting substring, do we even store that? Is that stored anywhere? It is, it's a slice. Well, really, it usually has one. I mean, O of n is that every... O of m is the length of the pattern. So we store the pattern, that's whatever. Then there's n, which is the string. And we take the if we take the whole string with us, then that's also a storage in the return. It returns it, but it stores it in a slice first and then returns it. So either way, you're going to generate that list regardless, that slice list. Where m is the pattern dict. I'll say pattern count. Dict and n is the string slice for the return. Yeah, I need to veg out. I have to come back stronger, otherwise I'm gonna burn out and not be able to finish this. Because I have to get through a lot of 2-pointer in the next 2 days, and also get past fast and slow, which I have no idea how long those are. So I gotta focus on that's fast slow. Fast slow is, oh, yeah, it's shorter, which is good. But the longest one was actually, longest one was sliding window. Oh my god, 2-pointer is also pretty fast, pretty slow. I mean, I gotta take Friday to get through it, because if I don't take Friday to get through it, I'm literally never gonna finish this. Uber Eats. I don't know why I'm on my phone. $30 off your last minute grocery order. Whack. I want me to the gas. Oh my god. Okay. If I need to go back and explain stuff, I can go back and explain stuff. Right now, I need to get through problem 4. I'm setting a 30-minute timer, max. Because I don't want to deal with taking too long. I will also check my Wi-Fi before I start. No messages. They have a UAT problem in Apex, so David is not available right now. Okay, that's fine. You're dealing with me, ref. Should I play music? My headphones? Probably. I need to turn down my desktop audio. Or my Spotify audio in particular. Okay. Well, let me get set up and then we'll start the actual problem. Words concatenation. Why did they give me 4 hard problems to solve? Can someone please explain that? Like, was I really supposed to solve that? Like, I believe myself, but damn. That was crazy. Just gotta keep plugging through it. Alright, problems here. I'll give myself a handicap. I'll say once I understand the problem, we'll start the problem. Words concatenation. What does that mean? This is some stupid code wars issue. Given a string and list of words, find all of the starting indices of substrings in the given string that are a concatenation of all the given words exactly once without any overlapping words. What? Given a string and a list of words, find all the starting indices of substrings in a given string that are a concatenation of all the given words exactly once without any overlapping of words in a given. It is given that all words are of the same length. Interesting. So in this example, we said 0 and 3. Why? Because there's cat, fox, which is a concatenation of cat and fox exactly once, no overlap. then fox cat, which is a concatenation of fox and cat, exactly once, no overlap. Then there's cat fox, not cat cat, but cat fox, and not backwards. Yeah. Crazy. Okay. How does this relate to our last problem? I'll start the timer now. How does it relate to our last problem? Let's take a look. So our last problem was what? We were taking the smallest window to find the pattern in a substring. So in other words, this words is an array of patterns. And we're attempting to find a concatenation of this pattern exactly once, end to end, no overlap, exactly once, end to end, no overlap within the string. Okay, so we need to keep track of, do we want to do the same thing before and say not really. Hear that? Some noise. Okay, if we do a more complicated data structure, character frequency can be an array of character frequencies. And what I mean by that is we could say something like, I'll write some notes. Actually, I'll put it on the whiteboard. So we can write some notes and just say character frequencies can be an array. Each word has its own character frequency. And so we can match with any one of them. So it'll be a list, and each word gets its own mapping. So we get cat and fox. So there'd be one C, one A, one T. Fox would have one F, O, and X. Right? The point here is to say that, we're going to look for an exact match, no overlap, no nonsense. Pretty simple. Now, what if it's cat, fox, fox? Then you'd look for fox, cat, fox, fox, or fox, cat. Concatenated, end to end, no BS. Now, could there be multiple? I don't know, maybe. It says, find all the starting indices of substrings. Okay, if I'm gonna borrow any code from our next, I don't know. Let's not think of code right away. Since we understand the problem, the point is then to understand how we can solve the problem. Since this is similar to our last equation, our last algorithm, I can't say equation. I'm tired. Catherine saying, I hear you, babe, but work's gotta get done. So I do it. Am I having an afternoon crash? Was that pizza and mac and cheese bad for me? Probably. But I ate it 2 hours ago. I can't believe it's still hitting me now. Why is my hand so tingly? It's sensitive. Okay. So, for the past 2 or 3 problems, we've used some character frequency object, right? And there's different ways to look at it, right? If I just take a look at this example, cat, fox, cat, with cat and fox as our words. If I see cat and then I see fox, the index is 0. If I see fox and I see cat, our index is 3, which means that we're going to loop over this probably one letter at a time. But there might be some inner looping to verify. Well, no. I'm trying to think for a minute. This is similar to the other one because we know that there's only a specific length. So for example, if the first word is length 3 the second word will be length 3, and therefore we know that length 6 or 6 characters make up that thing. So I'm thinking about the same window adjustment strategy as that one problem we saw. Which one was that? I think it was either anagrams or... Oh, that's why it looks weird. Hold on. Let me fix this real quick. Not important, but still important. I think it was permutations in a string, where we had to maintain like the window or something. Yeah, but we were adjusting the window. Where was it? No, something else. It was longest subarray of ones after replacement. So it's like that K replacement thing where it's like we know we can only have so many letters in our window to validate. If we have more than that, I guess no, it wouldn't work. You can't have anything in between, and anything at either end is throwaway. So there's gonna be a window management. So I think we're gonna be adding stuff to the window. I didn't even set up my coding environment, but that's fine. That's after the fact. So if I start at C, I don't want to expand my window to the right so long as the next letter is in like a frequency dict, but also like in the right order. So we have to spell a word, if that makes sense. So we can have a pointer that points to the first letter in our first word. Is that valid? Yeah. I mean, there could be an offset too. So it could be like 0. I mean, we can point to try to match our first word, right? So point to that, and then within it, we can point to like the character itself. Wow, somebody just walked by. No one ever leaves their apartments over here. So if the first letter is a part of... So really, what it is that if the first letter we encounter, if the letter we're on is either of the first letters of either word, then this has the potential to be a valid concatenation, right? So in this example, because we land on a C, right, we start on a C, this is why this is valid. Otherwise, we wouldn't even touch this. If it was an A in front, we wouldn't even worry about it. Okay. So we land on a C. We know that that's the start of one of our words. We have A. We have T. The next word, after we find or match the letters of our first word, the next letter, the F, needs to be the first letter. Well, yeah, I mean, we're going in order, right? We're saying this is 0, this is 0, 0. It's a nested array, really. We're saying this is going to be, 0, 0, and then 0, 1, and then 0, 2. And if we're still matching on the next time, we're going to say, once we hit the length of the first word and the next word is in, no, because we don't have to go in order. Right? So if we hit like fox, cat, fox, technically we point to 0, we point to 0, 1, 2, 3, 4, 5, 6. We point to 0 and we point to 6. So we're just traversing the array in order. Okay. But if there's more than one word, it has to be either the first letter of any word that we haven't already seen, unless it's in there twice. But I think that's not, is that even possible? Without any overlapping of words. So for example, if it was like cat and then like tack, it'd be CAT and then TAC, not CATAC. If that makes sense. Yeah. Yeah, I mean, really, we're just trying to understand, like, because it could be also fox, cat, fox. And in that case, F is the first letter of one of our words. And O and X are, okay. So depending on what letter we fall on, we might say like our current word, is, and then it's gonna be like it's gonna be like an index. Our current word is, I feel like I'm so behind on the solution. 18 minutes. We only care about the F or the C because they are the first letter of one of our words. So once we see an F and once we have the C, we might set like some word to be either cat, or fox. And then we from there say we expect to see an O and an X after this. If for some reason we see like FAX, this is not valid. Right? Skip. Next. We don't care. So we have to have a pointer. So we'll have some mechanism for finding the word that we need to search on. Then we'll have a pointer to where we are in the word. So if we see an F, then our current word is fox, and we're going to loop through our string looking for the rest of fox or whatever the word is. And then we hope that once we reach length -1 of fox, in terms of like index maybe, then we're looking for, then fox is no longer eligible, and we're looking for the first letter of another word. And we're looking for the first letter of another word. So because we see a C, great, that matches a C, right? So we're going to start with at least some for loop for let in string, right? We're going to say, we're basically saying if our current letter is the start of one of the words. That's a little bit tough, right? We'll say if let is start of one of our words. We only care about looking into this if letter is the start of one of the words, the start. Not in it, but the start. If it's an X, that's in fox, but you can't spell fox cat or cat fox starting with X. It doesn't work. So we care about it being the first letter. Okay. And it can come in any order too. So our start, out here, starts at 0. And our start gets bumped until we find the first letter of anything, right? So there might be some bumping code out here. Then we're saying if letter is the start, while the next letter matches the next letter of our word, continue down. And then eventually when we have the length, update our word with, I guess, update our word pointer with the next word, something like that. Something where we're saying, okay, let's say we find fox, we're then looking for cat or the next word. And we need to see then cat or another word in our words array follow that. So I guess iteratively try to map. I guess I'll say look at each look at the next, I don't know, n minus 1 letters for match. Okay. We know that our match needs to take on, 3. So for example, if we pick the first letter or for the first word, we know that let's see. So I said look at each next n minus 1 letters for a match. So we found F, look for O and X for a match. If we find C, look for A and T as a match. Because there was no letter interrupting this, right? So if they all match, then we store, return, I'll say that append our start. Our start points to F. We found foxcat from there. Sweet. Then what do we do? Well, do we run the algorithm for each one? Well, only if it's the same one. So, there's a chunk of code that says match the following letters, or look for a match in the following letters and one of our words. That's this code that does that. Then I'm assuming if that doesn't work out, then start gets bumped up 1, and then the next time we'll ask, well, we want to keep track of where we are in terms of like start position. I mean, we already know after this that, but we don't care about like that kind of runtime, if that makes sense. I would like to say start gets the next, like gets F. If we have fox, cat, fox, I want to say start gets F. We can't do that right away. So we'll be ending on T. So I would say start gets n plus 1. I mean, we're gonna run a. I'm so tired. Wow, eating food, heavy food, but we're doing intense work is a bad idea. Especially without enough sleep. I only slept like 6 hours, so that also might be why I'm tired. But getting through this will be great. It'll feel great. It's 2 o'clock. So I have time to DJ or play some games before I have to go dash-ish. The dash starts at what? 3-ish? Not busy. Promotion at 3, worth $250. Uber Eats, what you got for me, man? A little busy. We'll be busy around 5. I got 10 opportunities. What? Guaranteed 22 an hour. Guaranteed 22 an hour. Why? What is this? I'm wasting my valuable time, I know. Oh, interesting. There's some crazy ass $6 extra by completing 6 trips starting at 5 p.m. today between 5 and 9. That's some cool ass quests. I'm gonna check these out in a minute. I just get $12, or is it like 12 per? I don't know. I'll have to read on it later. Anyway, I gotta check my phone. I don't know. I don't. I mean, the last problem was like, oh, we matched. Okay, so what? So we can maybe keep track of a match and say like, continue to iterate over this until what are the conditions, right? Well, the conditions are, we've exhausted our words and we've continued to find matches. So in layman's terms, we can figure this out. The code itself needs to be written. That's the part that I'm like, I need to learn how to write because I'm just like, I don't know. It's all in theory. It's all pseudocode. So we could keep track of match and say like, I mean, match is basically length of the first word times, length minus one of words. So for example, match would need to be, or I said, match would need to be 6, right? So that would be length 3 times 2. Length 3, it's 3 words times, it's three letter word times 2 of them. So we could say, okay, we need to be, we need to hit how many matches in a row. That's kind of the theory. So okay, I think the approach to these problems is work out the conditions in English and try to translate the English to code. The better you can describe your English, the better you can write the code from the English. But the more you understand about how to translate it, the better you can translate it. So we're gonna take a look at each letter for sure. We're gonna say if the letter we're on is the start of one of these words, it could be fox or it could be cat. We need to find the start. We can't look at T, we can't look at A or O or X. It needs to be either a C or an F. It needs to be either a C or an F. We could take an array of the starts and check that. So I could say like C, you know, hello? This is dying on me? Question mark. So we put C and F in an array. We say like if letter in starts, right? Then we can start this loop. Huh. I don't like that. My man just starts right now. But the idea is there, right? The idea is that if the letter is in the start of one of our array, I keep saying that. Then we'd say, okay, look at the next one. And if we are pointing, we're tracking the word itself. Well, we could start a dictionary, right? We could say like, we could say C maps to cat and F Maps to Fox. That's not gonna work. If there are two F letters, that's already bad. There could be collisions there. It's not gonna work. There could be collisions with keys. 5 minutes. God. I keep overthinking the problem before I even finish it. That's my problem. Cat and fox. Okay. So as we're looping through this, we'd say if this letter is equal to, then we'd want to then, ugh. I'm trying to think here. Our last solution looked like what? The only part we have here is while matched. Then it says left gets left at start, update your start. Then it says if the left is in the character frequency, then so we can't use the same tactic because we need to match the words exactly. So I'm saying that, okay, as I'm looking at this list or at this string, if the letter I'm on, is a part of one of the words, cool. Even better if it's the start of one of the words, extra cool. So we start on C, and because C is the beginning of one of our words, we're curious about what comes after C. So we say, we'll take a look at everything after C, right? Or let's say, take a look at the next. How many characters after C? If they match up with cat, that's good. We can continue looking at this. If not, it could be like a CCAT. But the point is that we only really want to dig into this if I'm kind of giving up right now. I'm kind of giving up. Because I don't want to just get solutions. I want to actually solve the problems like the way they're supposed to be solved. So I'm just like, I don't want to just get a solution and say I moved on. I want to actually understand what happened. But maybe I'm a perfectionist trying to figure this all out. I'm droopy. Need a break. Need a big break. But I do want to start 2-pointer tonight. No one else is online. But also, it's holiday season, so I doubt people will be online. If not, I'll just have fun on my own and kill some time, I guess, while Jasmine's out. But I don't know. I mean, we could just take a window the size of, I don't know. I gotta figure. I'm getting complicated in my head. My solutions are not. I'm not sure how to apply a sliding window to this. That's why I don't think I truly understood this last problem. I understand it now that I'm looking at it, but I don't know how I would have gotten to this solution. Now I did come up with the idea of keeping track of some kind of min length, not storing it as it is, but saying like, but storing like the beginning and the end, which I'm sure you could refactor this to do that. But they're saying that they did min length, they did start plus min length. So doesn't send me movies. I watch those in a minute. Yeah, I think I'm just gonna call it. Let's take a look, my boy. See how far off I was. Rough, you're doodling with me. Let's read the solution first. Problem follows sliding window and its maximum sum subarray of size k. Okay, so that one seemed, it did seem similar. It said maximum sum of size k. Let's take a look at what that problem was. It was, thank you. Oh, it was one of our easy problems. What? That's a hint. I could start it over for now and take the hint, but it said it was similar to that problem. How? We'll keep track of all the words in the hash map and try to match them in a given string. Here are the next steps in a hash. Why are they using a hash map? Keep the frequency of every word. Oh. Starting from every index in the string, try to match all the words. In each iteration, keep track of all the words that we have already seen in another hash map. If a word is not found or has a higher frequency than required, we can move on to the next character in the string. So the index if we found all the words. What? Okay, I have a little bit more energy. They said, so we're using 2 hash maps. One to keep track of the frequency of every word. Oh, like from words? So there's 2 cats. K. There's 1 cat, 1 fox word. And we're looking to try and spell cat and spell fox right together. How are they doing this? If length of words equal to 0 or length words 0 equals 0. So if there are no words or the word's empty, return out. Words frequency, so 4 words in words. For every word, add 1. Okay. Words count, length of words. Words length. Excellent. So for I in range of the length of string 1 minus the words count times word length plus 1. What does that mean? That means we're taking, for example, cat, fox, cat, which is what, 9? 9 minus word count is 2 times 3, so 6. 9 minus 6, 9 minus 6 is 3, plus 1 is 4. So, we're using 2. I'm using nested loops. What? We didn't even use nested loops on this problem. That concerns me. We didn't even use nested loops on this problem. Okay, anyway. So words seen for each letter we track. Oh. So I thought of that. It's on record. I thought of like, oh, we could only look at 6 characters total. Or at least I said the window would be 6. Once you look past a certain index, it just literally can't exist. So it cleans up the function there. So go from 0 to words count. And words count is the number of words. So we go from 0 to 2. So 1 is I plus j times word length. Next word index. So the word, haha, that's crazy. So they found a way to get the word itself without having to loop over. That's insane. So if word not in word frequency, then break. If word not in word seen, that's insane. Then we say, okay, word seen for this letter. We're trying to get the next word. So we're saying if word not in words, if not in the frequency at all, get it out. If we haven't seen it yet, give it a 1. No need to process further if the word has higher frequency than required. Break if j plus 1. So if the yeah, okay. I would have never gotten this. Wow. So then it says if j, so j is our word scanner, right? So j tells us what? J is used to calculate the next word, and it's offset by the word length. So for example, we'd start at 0. We'd say 0 plus 0 times 3, 0. So we said word index 0 to word length to word index plus word length. So it'd be 0 to 3. That would grab 0, 1, 2, not inclusive of 3. That would grab cat. Is cat in our frequency, right? Yes. Word not in frequency, false. Word not in seen words, add it. So it's in seen words and it's at 1. If word seen word greater than word frequency dot get word, it's a safe get. It's a safe get. So what they're saying is, so if we've seen cat, so if 1 greater than 1, break. Or if we see 2 cats, 3 cats greater than 1 cat, break. Otherwise, if j at 0 plus 1 equals words count, so j plus 1 equal word count. Oh, so it's we're using j as like an index, like an offset. Or no, we're actually using, yeah, we're using j as an offset. J times word length to be an offset. Crazy. This involves so much more than sliding window though. Like this involves the ability to do an offset and then pull out the word and slice it. It's like, oh my god. All right, then so everything went through just fine. We didn't break it all. We hit J1. So we have i's at still 0 plus 1 times 3. That's now 3, index 3, 0, 1, 2, 3. Whoa. Fox not in, it is in. Fox not in scene, right? And then move it to plus 1. If words, Fox 1 greater than Fox 1, not. J is 1 plus 1 equals word count 2. We added it. So we added our append I. Our I was at, you want to know something? So why does that return because we technically already added we had I. I'm confused. So 0 to words count. So words count is just 2, correct? We only counted 2 words. Oh, so we go 0 and then 1 and we'd append what? Oh, I is still, so we append 0. Great. Then I goes to 1. So I goes all the way, I think, to 3, or is it 4? 3, 4. Index 3. But it's going till 4, 0 to 4. So then we say, okay, J word count is 1 plus 0 times 3. F, we take the slice. So we get 3 plus 3 to 3 plus 3, 6. So 3, 4, 5 is our indices. If word not in, and then word seen gets reset, we added 0. So there's, okay, cool. No, I mean, it makes sense. Yeah, I followed it. But it's like, how the hell would I get to that equation? I think it'd be worth doing a review session of each problem and making sure we can write down in English, or at least in comments, what we actually saw here. Because I was like, I don't even know what to do. I was literally just like, it's good to use other solutions, but this one required, I guess, something that I might have done. I don't know. It was just weird. But we're good. I'm going to wrap this up, and we're going to do something else with my time because I'm exhausted. Never pace right. Turn that. Word. Okay. Result indices. I'll go that way. This for loop. I'll go that way. And that can go all the, I think also go in here, right? Am I insane? Yeah, everything goes in the for loop. This also gets adjusted. Sweet. This could be one line, right? Am I crazy? Say tests. I could say PyTest. Dot mark. Dot parameterize. I could say we have our string. We have our words. And we have our expected output. I'll just say tests. Create a function. Def tests. Test what? Find word concatenation. I'll just use str1, and I'll use words as like examples here. We'll just say str1 is a string. Words is a list of strings, and then expected is a list of indices or ints. Okay, I'm going to assert that our find word concatenation, if you pass in str1, you pass in words, should equal expected. I'll write two definitions real quick. Cat, fox, cat. With, whoa. And then we'll also add our words, which is just this. This should say 0 and 3. Cat fox, and this should say 3. Okay. PyTest dot run. Complexity analysis. Let's run it. I might shrink the rest down because this is a little complex here. I'm looking at, if I were to look at it myself, I mean, it'd be I to the range. It's not n. It's really like n minus something, right? So it's this. But what is this? I mean, gotta find another way to calculate that, right? I don't know. It's n. Oh, crazy. Haha. It's n times m, number of words, and the length of the word is our literal space complexity, time complexity. So it's big O, n times m times length of something, where n is the length of the string, m is the number, and len is the length of each word. Okay. It feels so arbitrary sometimes. O of m for words in a hash map, O of n for if the word is A, I guess those are all valid. Well, no, you have to have as many A's as, I guess. Okay. Where m is of the words, and n is the result list of indexes. Okay. Wow. So rest of the oh my god. Terrible. Done. I'm out of here.